So electrical safety testing is something that's been around for a long time, decades. It was intended to protect operators and anyone handling devices from electrical shock. And it also had the ability to protect against fire safety as well for various types of equipment. The equipment that CROMO offers is a wide variety of equipment that can do various types of tests. And we're going to go through some of the basic tests with a brief description. Starting with ground bond. Ground bond is probably one of the simplest tests to perform. It basically tests the integrity of the ground connection from the input safety ground to the any of the metal housing and metal components that make up the device. And to do that, we pass a current, a regulated current, through the ground conductor while monitoring the voltage across it, and then we can calculate the resistance of the conductor. And by doing that, we can determine that it is an adequate size rated wire or conductor to meet the requirements. This is again a fairly simple test to do. We have a variety of equipment that can handle that, and I'd be happy to go into more detail with that if you need it. We also do AC and DC high voltage withstand testing, which tests the insulation rating of the device. This is done by placing a high voltage between the line neutral conductors shorted together on the input of the device, and then measuring that with respect to the ground or chassis of the unit. And then the leakage current would be measured across to see if it is a substantial amount of current that could cause shock hazard. And there's various standards for this, but it gives you the ability to accurately measure that current and to identify if it meets the low levels per each of the individual standards. Leakage current testing, as we just talked about, is a way to identify that the human body network, which is a simulated impedance of the human body, that the current through the device when high voltage is applied does not exceed unhealthy level of current that would cause a shock hazard. Fault conditions when doing these kinds of tests are to simulate possible faults that could occur on a device, such as the reversing of the line and neutral input connector, and also the possibility of the removal of the ground conductor. So any of these things could present a shock hazard to the operator, and these are tests that are defined in various standards such as 60601-1. Earth leakage also is a test that is performed. This is the most basic leakage current test. This one, again, is looking to see that if there is any current flowing through ground that could pass through the operator that could cause a shock hazard. Enclosure touch leakage. This is where if an operator places his hand on the device that is a conductive material, such as a metal enclosure or chassis, that he will not be exposed to a shock hazard. Patient leakage, the same principle, but there is more extensive testing. There's various tests to confirm that when the patient touches a device that they don't have access to leakage current that could cause, again, that would cause any kind of a shock hazard. And with this one, there are what they refer to as human impedance networks, and we'll go into that in more detail, the variations of that for the different standards. There's another type of patient leakage. This one is where there would be a second source of power that would be accessible to the patient. And this would be if you, for instance, the patient had a type of test equipment attached to the patient, and then the patient were to reach or be touched to another device, that there wouldn't be a differential voltage or any way that there could be a shock hazard based on that. And this is defined in IEC 60601-1. And with that, we can also do testing to simulate that, and we'll go into that in more detail with our actual equipment. Patient auxiliary leakage, again, it's from one patient lead to another patient. For example, if you were in close proximity to another patient while you were attached to a piece of medical equipment, that would give you the ability to make contact, and then if there was that point-to-point contact, that there may be possibility of leakage current flowing through that could cause some kind of a hazard. The standards that we're going to look at, there's a variety of different standards, but the basic ones that we'll cover are basically the house appliances, IEC 60950, which covers information technology, video, audio, house appliances. The UL 61010 covers lab equipment, and 60601 is medical equipment. We also have various standards for UPS and power transformers, and there's new standards coming out all the time, such as for electric vehicles, the new ISO 6469-1 and -3s. So IEC 60950 standard has some requirements for open and short testing. This is not a mandatory requirement. We include it in all of our test equipment. And what this is for is to confirm that the test equipment is properly attached to the device under test. And with this, you can ensure that when you perform the test, that it is being performed properly, that you won't get any false pass due to the fact that it may be open circuit. The other test is ground bond testing. We covered that briefly. This is a way to ensure that your internal ground conductor can carry sufficient current. The ground conductor has to be capable of handling the amount of current that the device would see if there was a short between the input power to ground. AC/DC high pot, we covered that briefly too, and that would be if there was a insulation breakdown that would cause current to flow back through the earth ground, and that also would, cause a problem with the leakage current that could cause a shock hazard. There's another level. Go ahead.
I got a question about your AC/DC withstand voltage high pot testers. What kind of current levels, or what kind of current does it put through when you charge your system for, like, say 1,000 volts? Because I'm not looking forward to potentially damaging any of my systems if I perform this test.
Sure. Well, the current, our chat line is open, and basically we can program that current level from microamps to milliamps, and it can be done accurately based on whatever the standard requirement is. We have high current levels that will give you up to 120 milliamps or down to as low as a few microamps. So it is programmable. It is something that you can do, limiting the amount of current through your device.
Thank you.
So the IEC 60950 standard also includes requirements for ground bond, and it also includes requirements for high voltage withstand and earth leakage current testing. Within this standard, which is for information technology products like computers, printers, projectors, etc., it also has the leakage current test, which uses a certain type of measuring network to simulate the impedance of the patient or the operator or anybody that would come in contact with the equipment. The IEC 60335 covers household appliances such as refrigerators, ovens, coffee makers, and they have different classifications, and each of those classifications have different leakage current levels, ranging from 0.25 milliamps all the way up to 5 milliamps, depending on the classification of the device. It too requires ground bond, AC/DC high pot testing, and the earth leakage current test as well. The reason I'm showing these is because you're going to find that most of these do require similar testing. The level of testing and the accuracy of the measurement of the leakage current will vary based on the devices. 61347-1 covers the lighting industry. This is just a brief coverage of that. Again, this one will give you requirements for ground bond, high pot, and earth leakage. And again, it has different levels of leakage current, and those are defined based on the IEC 60990 measurement network to identify based on the different human body impedance simulations. And then, of course, the most stringent one would be the medical industry, which is the IEC 60601-1. This one does get into some additional leakage current test requirements, such as the enclosure leakage current test, patient and patient auxiliary testing. And here I've shown just a quick view of the various different types of impedance networks that would be used to simulate various human body networks or impedances. And they do vary, as you can see, based on the standards. So CROMO has a vast number of different types of test equipment to cover all the different needs. And so what we have to offer is based on standard basic AC/DC high pot testers, starting with our 19070 and our 19050 family of products. These will give you a basic AC voltage high pot test, or AC plus DC high pot test, and insulation resistance test. And with these, you can do up to 5,000 volts AC, 6,000 volts DC. Very good resolution on the settings, very accurate on the measurements. So with this one, you can do 2-volt resolution, and depending on which model, you can go anywhere from 20 milliamps of AC current, 5 milliamps of DC current, and you can go 30 milliamps of AC current up to 10 milliamps of DC current. All of our products offer what's referred to as flashover arc detection. We're going to cover that in a little more detail. This is a little a better way of doing the actual flashover or arc test with respect to how a typical high pot test might perform it. And then also the insulation resistance testing with these devices all the way up to 50 gigohms, which gives you an accurate measurement voltages up to 1 kilovolts. All of these products have the ability to protect the operator with ground fault interrupts, and some of them have multi-channels to give you better throughput, or for devices that that have multiple contacts that need to be tested. Some of our devices have GPIB interfaces as an option. All of our units come standard with RS-232 and control signals and status signals. If you have a higher volume requirement, CROMO offers the 19020 high volume EST testers. This one gives you up to 10 channels, with each of these being able to be grouped together for up to 100 channels total. Also has a feature known as synchronous high pot testing, and what this does is this gives you the ability to ensure that when you have multiple channels side by side, the voltages are synchronized so that they will not produce a high differential voltage between the channels. By having the voltages synchronized, they will always have a 0 volt proportionally between the two channels to prevent excessive high voltage. These units go all the way up to 6,000 volts DC, 5,000 volts AC. They too have good resolution, 2 volts, 10 milliamps AC, 5 milliamps DC, and insulation resistance up to 5 gigohms. They also include the arc and flashover detect that we're going to cover in just a moment. These are perfect for high volume type testing. Anything from power cords, capacitors, switches, connectors can be done in high volume with these products. So when we talk about flashover and arc detection, the difference between a flashover and arc detection type of high pot test is basically the ability to do a higher sample rate of the measured current, and to be able to determine that that small anomaly is detected. Because over time, these small types of flashover or small types of interrupts or different types of leakage current at high frequencies could eventually become a fault in the field. So by doing a higher sample rate, we're able to detect that and prevent it from occurring in the future. So normally you would be looking at a standard low bandwidth leakage current test, like the one you see here in Figure 1. And when you measure that, you would not be able to detect any kind of short duration, high frequency anomalies like we can with the higher sample rates. To get into more advanced type testing, CROMO offers the 19032 and the 19030P combinational testers. With this one, we can do the standard AC and DC high pot testing and the insulation resistance, but we can also do ground bond and leakage current all in one unit. With this one, again, you get the standard 5 kV AC, 6 kV DC for AC and DC high pot testing, but it also gives you higher current capability for devices that have higher impedance insulation. You get up to the 40 milliamp AC and up to 12 milliamps DC on our standard 19032s. And then with the 19032P, the high power version, all the way up to 100 milliamps of AC current, 25 milliamps DC, ground bond all the way up to 40 amps. So we also offer with this one the ability to have optional interface scanner, internal scanner cards. And what these are for is to, they have the various types of relay connections to simulate the faults that we discussed earlier for open and various types of fault conditions, like switching the line and the neutral, or opening the ground wire or the neutral wire during the test to see if it has an adverse effect on leakage current. It includes the flashover detection. It also has the open and short circuit check, and it also includes the testing for various types of control signals. The 19032P also, as I mentioned, has higher AC current capability, and it has the higher ground bond. It also gives you the output floating compliance, which is another way to protect the operator. Ground fault interrupt is one way to protect an operator, but completely floating the device so there is no possible leakage current connection to the operator when they are connected to ground. It's a perfect piece of test equipment for the medical industry, IEC 60601 and of course 60950. I talked a little bit about the different scanner cards that plug into the back of this unit. These are the different options that we have. And with this, you can include up to 30 amps, 20 amps, 300 volt for doing the various types of line fault conditions and earth, ground, and neutral to simulate the fault conditions as well. And so these plug into the back. They're easy to set up and control. And again, they can be programmed internally to simulate those faults for the variations that we had talked about earlier. Another feature on the 19032 is the ability to combine test. Typical conventional tester will give you a ground bond test, and then will be followed by a high pot test that are done sequentially, and it adds to the total test time. In our unit, you can combine ground bond, and you can combine those together to create the same test at the same time to cut down on your total test times. Another feature that we've added is the ability to do corona or partial discharge testing. And there are, for this one, there are a more advanced way of detecting very low levels of the corona partial discharge, which has to be done through a much higher speed of measurements, and this can be done through advanced sample rates at higher bandwidths. So by doing that, we're able to detect these small anomalies that, again, could be causing failures later down the road in the field. And so I've got some more information on that we're going to cover in just a moment. But this unit also has the built into it insulation resistance testing, RS-232 USB. It also includes a handler interface, safety interlock, all the standard interfaces, and has an optional GPIB. Another feature of the 19055C is for you to do a discharge level analysis of your device. And what you can do is you can program in a ramp type test at different stair-step tests to determine if your unit has potentially a corona, or a test where you start to see the lower level breakdown or leakage or partial discharge occurring. And also at the higher level, you might start to see that looking like a flashover or an arc, and then of course into total breakdown. The way we do this is we do a very slow ramp up of the voltage while monitoring your unit, and we are able to, with the very high sample rate, be able to detect at very low levels these different types of changes in the actual current changes for the for corona and for flashover. And we've got another slide that covers this in more detail, but I've also showed a screenshot of it. Over here, the screenshot on the front of the unit will give you a particular measurement in current for the arc detection at a different current level. It also gives you a proportional number for the peak measurement of the corona, which is a 0 to 99 reference proportional value that would indicate that you're starting to see some level of corona occurring. So when we talk about corona, we've added onto the 19055C the ability to view the corona and the arc signal through a monitor signal on the back of the unit. So when we look at the corona or the arc comparison, we'll see that it varies greatly in amplitude, but it also varies greatly in bandwidth. So when you look at these, you'll see that their amplitude can be very small, and that they're also at a much different frequency. And when you look at the chart here on the right-hand side, you'll see that there is different bandwidths for those. So when we look at a typical breakdown, you'll see that it occurs typically in the range of the line frequency and up to maybe as high as 10 kilohertz. But once you start getting into arc and flashover, you'll see that it's a much shorter duration, and it occurs in the range of maybe 10 kilohertz up to as much as 3 megahertz. Once you get above that, you'll see that it starts getting into what we refer to as a corona discharge. And our R&D group at CROMO have done a lot of evaluation. They've worked with various universities to be able to identify and characterize the differences between a corona and an actual arc and an actual breakdown of the when you're doing a high voltage test through the insulation. One other characteristic of this is that when we run this test, the bandwidth filter that we use it can go all the way up to as high as 200 nanoseconds per division. So with this, we can very accurately and with great precision be able to differentiate between the corona discharge versus an arc. And when we look at this through this high-speed sampling, and in addition to viewing it like you do here, you'll see that we're able to identify clearly that there is some kind of anomaly going on within your unit. And over time, this can cause a deterioration of the insulation. And this is something that more and more customers of ours have been looking into how to identify these things to prevent those failures later on in the field. Another advanced tester that we offer is the 19035 and 36. And this one is specifically for wire wound devices. And this does something that we refer to as impulse winding testing, and it also includes DC resistance measurements. For this one, the impulse winding test, again, is a unique test that will check the winding to winding characteristics for insulation breakdown on wound components such as transformers and electric motor stators and various types of coils. This one again has a very high measurement sample rate, gets all the way up to as high as 200 megahertz bandwidth. And with this one, you can go with an external scanner box up to 40 channels. And again, it has a standard Ethernet, USB, and RS-232 interface, and it will also protect the operator with GFI. It gives you the ability to do higher currents up to 120 milliamps of AC, 20 milliamps DC with the 19036. This one is also, we offer a 19035 version of it that doesn't include impulse winding test. And it also includes DC resistance, which is a key measurement for testing coils and transformers, inverters, and it does it with a 4-wire DC resistance measurement, and it's perfect for doing the balancing testing for delta and Y windings on a transformer or electric motor. So DC resistance is included on this one specifically because it's a typical test ran for most transformers and stators, electric motor stators. It does a DC resistance 4-wire, or you can do a 2-wire measurement if you need more channels. With this one, you'll be able to accurately measure as low as 0.1 milliohm or 100 microohms, all the way up to as high as 500 k ohms. This tells you that accurately determines that you have the proper wire gauge and that there isn't any shorted turns within the windings. It also it can be used for DC resistance balance measurements, especially on motors. Imbalance windings, different turns will definitely can cause some winding anomalies that cause an imbalance in a stator. With the added temperature probe on this one, it also gives you the more accurate capability of measuring the resistance at different temperature levels to ensure proper compensation and at those different temperatures. Impulse winding test is a very unique test. What we do is we actually can impulse the way that we do this is we actually inject or impose a charged capacitor across the actual inductor of the winding. And when this occurs, it creates a ringing. And the ringing effect, we can do a high-speed analysis of the ringing of the voltage. And during that time, we can see various types of changes when we compare it to a known good part. These changes include things such as the area and the size, the differential area, flutter value, and what we refer to as Laplace value. And I'll go into those in a little more detail. But by doing a high-speed measurement of this waveform, we can do a very good analysis to see if there's any alterations that might reflect that there is a difference or an imbalance, or even that there might be a partial discharge occurring between the windings. So there's 4 ways that we do that. There's 4 types of judgments. One is the area size, which determines the DC, possibly the DC resistance of the wire, but it also can tell us if there's any shorted turns or any difference in the winding themselves that might cause a various imbalance or difference of the inductance of the wires. Differential area, this is looking at possibly a variation that would be related to the, again, possibly shorted turns, but it also could be an indication of the actual inductance of the coils. Flutter value, this would be something that would be a possible anomaly related to a possible partial discharge that's occurring winding to winding or layer to layer. And with this flutter value, you might be able to detect a very fast, sudden change. And with that change, it could only be detected with the high-speed sampling that we can do when we evaluate the waveform. The same type of test at a different level would be the Laplace test, which gives us the ability to do that and also detect such things as corona or partial discharge. A typical test would look something like this. I apologize for the, I took a quick snapshot of the 2 screens with my camera, and they didn't come out the best. But you can see a typical good waveform with the top program view. And you'll see that when we impose that pulse of short duration voltage applied from the capacitor, and as it starts to ring, you'll notice that it's a fairly clean waveform. And then down below, you'll see on a failed part, you'll see that it starts to cause it to see that partial breakdown, which would be the differential, which would be the partial discharge occurring. And then it would be something that would show up also in the what we refer to as the differential area as well. So, and those are indicated below by the voltage at a lower voltage, and as the levels that we've detected for a fault on Laplace and flutter as well. And so from there, you'll see that you can clearly indicate if it's a passer or a failed condition. We also offer a range of high voltage types of high-pod testers. We go all the way up to 20 kilovolts for some larger devices that require the higher voltages. The 19057-20 gets you up to 20 kilovolts, and the 19056 gets you up to 10 kilovolts AC. We also have an independent 19057 ground bond tester. This is a way to go up to 45 amps if you already have your own high-pod test equipment. You just want to add ground bond. This is another way to do that without having to go into purchasing another group of testers to do that. The one thing that I also wanted to mention is that with these products, we do full integration of system integration to do a completely automated tester. And with that, you can, our system integration engineering group here in California can create you a fully automated test system to do that for you. And we'd be more than happy to go into great detail with you We also offer a software package, and the software package for this one includes the ability to do, let's go here one more slide. Gives you the ability to set up all your configuration for your actual equipment, save and store that configuration for different types of equipment, and also to do the parameter settings. It has predefined parameters for each of the different tests. The tests are predefined for you for high pot and for ground bond, insulation resistance, open short checks. They're all well defined. Each screen has all the parameters that you can fill in and then save and store that information. We also have with that a great display screen for your operator, and that will give you all your pass-fail results. And from there you can also collect that data into a nice report. You can also do database analysis and statistical analysis of all the data, and that will also be a part of this software package. To make it easier for you to select the proper equipment, we offer a selection guide, so that I've included that in this particular presentation, and it breaks down the different levels for the different types of tests that each product can do for AC high pot, insulation resistance, ground bod, and from there you'll be able to select it. But of course, feel free to contact myself or any of our salespeople. We'd be more than happy to help you with selecting the proper equipment for your testing. It also, as you can see, covers a variety of other unique test features on these units. These are what we refer to as sub-function testing and remote interfaces. So everything from open circuit, open and short circuit testing, ground fault indicator, and then also the various types of remote interfaces. And again, it covers it through all of our equipment, and we are introducing new equipment all the time, so please keep in touch with us. Would like to keep you up to date on any new safety equipment that we offer. Thank you very much. I appreciate your time. Again, we have a lot of people out there that are logged in to chat. They'll be more than happy to answer any of your questions for you. I'll stick around also and help with the questions. I apologize that we got off to kind of a rocky start, but now I'm more than happy to help with any questions. So please jump into chat and let us know if we can help you in any way.